Yeah, we were talking about the variables, the two variables involving global warming, which one is the carbon dioxide in the atmosphere, the other is the temperature of the Earth, and those two are related. The temperature of the globe, and we know now that the Earth has been warming for the last at least 100 years, 150 years, by direct measurement of the atmosphere, and it's gotten more and more sophisticated. And because we've taken thousands of measurements all over the place, they measure all in the Arctic, in the Antarctic, they measure above the oceans. I don't think that was ever done before. Every region, every continent, I believe. I don't know. It's thousands of data points. So the hottest year on record, okay, and this is Wikipedia. If you Google hottest year on record, you get the hottest year was 2016, and that was 1.69 degree Fahrenheit anomaly. That would be above, anomaly is above the, I think it's a 30-year average, baseline average. So 2016, hottest year on record. Second hottest year is 2015 with 1.62. And by the way, 1.69 and 1.62 Fahrenheit, it's not like a little within the margin of error, like a little blip or a static or whatever. No, it's a significant difference from the baseline average. Okay, so 2015, second hottest year on record. Third hottest year on record is 2017, 1.59 F anomaly. And the fourth hottest year on record, 2014, is 1.33 Fahrenheit anomaly. That means that this decade will be the hottest decade on record, probably by a large margin. So there isn't even a debate now, Scott. There is no debate on whether the Earth is getting warmer. The graph is just going up, and I think the rate of heating in the last 10 years has increased. So it's getting hotter at an even faster rate. But I don't know enough about that, and I'm not a climate scientist. I'm just familiar with these arguments. Let's see. Oh, and then let me just. I stumbled upon another thing to worry about besides carbon dioxide. Carbon dioxide is the main driver of the greenhouse effect. It's the main gas driving the increase in temperature. There's another gas to worry about, which is methane. Now, a lot of us, this will be very scary. So maybe you don't even want to listen to this. One of the scenarios is that methane is in the Arctic region, in the tundra. There's methane gas trapped in the tundra, and there's a certain amount of methane that's released by human activities and drilling for natural gas. Except methane is natural gas. Methane is an extremely powerful, more powerful than carbon dioxide as a greenhouse gas. Now, if you get to the point where the tundra starts melting, the tundra is melting now. That's another indicator. There's so many indicators, you can't keep track of them all of global warming. So the permafrost is melting, and that's releasing methane. And actually we're starting to measure methane, and the methane it's a very trace amount at this point. It is going up, but so it could develop into what they call positive feedback loop. In other words, it gets warmer. There's more methane in the atmosphere. The more the methane in the atmosphere, that increases the temperature. That releases yet more methane that's trapped in a frozen form, and it's just a vicious circle. So that's the second greenhouse gas, which most people we don't even go down that road. It's makes it more complicated, more difficult to I would just concentrate on CO2 because that's a big, huge problem. Then, so the positive feedback loop. The other positive feedback loop is the melting of the Arctic ice cap, which reflects light. It's white. It's snow and ice, and it reflects light. If it melts, that Arctic area without ice will start trapping the sunlight and the heat. Okay, not reflecting it. And then no albedo effect. That's in the positive feedback loop. Scott, maybe you know this. I'm sure Donald Trump doesn't know this. I'm sure he doesn't know what albedo means. I'm sure he doesn't know about reflective qualities of the Arctic. But hey, we don't need a smart president. We need a real estate guy, phony real estate guy. Bankrupt 6 times. Sorry. Wait, okay, I got to stop. I can't go down. Okay, so the other let me see. The other thing I was mentioning was the amount of CO2 being dumped in the atmosphere every day by 7 billion people. There's 7 billion people on this planet. And I thought it had to be a million tons of carbon dioxide every day, because people are driving cars, there's trains, there's buses, there's airplanes, there's manufacturing, there's tractors, there's generation of electricity, et cetera, et cetera. So 7 billion people burning coal and burning fossil fuel. This is daily. I have calculated here from a number, yearly number. I have 100 million tons of carbon dioxide emitted every day in the entire planet. And I get that figure from, 36 billion tons of yearly emissions of carbon dioxide. So that's one other thing to consider. 36 billion tons of carbon dioxide and as I said before, it gets the level now of carbon dioxide in the atmosphere is 410, a little bit more than 410 parts per million. That's going to have a significant effect on the trapping of the heat in the atmosphere. Sorry, that's chemistry. This is basic chemistry. It's going to keep going. It's just going to keep going. The more we burn, the more people there are, the more people that burn fossil fuels. That number is going to be going up. It's going to be 500 parts per million. So Scott, you tell me that that's going to have zero effect. By the way, I also mentioned ocean acidification. That excess carbon is being dissolved into the ocean. So the ocean has got more carbon in it. The atmosphere has more carbon in it, carbon dioxide. The oceans have more carbon. It changes forms. It dissolves in carbon dioxide, and it becomes carbon and something else. I can't remember. But it acidifies the water. Well, I better stop.